Hello, Dr. Lu. Welcome to my weekly report. Today, I would like to talk about data polymorphism, Java polymorphism. Since our data view has a lot of codes, we can organize them effectively by implementing Java polymorphism. So, the word polymorphism literally means a state of having many shapes or the capacity to take on different forms. When applied to object-oriented programming languages like Java, it describes a language's ability to process objects of various types and classes through a single uniform interface. Polymorphism in Java has two types. Compile time polymorphism, static binding, and runtime polymorphism, dynamic binding. Method overloading is an example of static polymorphism, while method overriding is an example of dynamic polymorphism. An important example of polymorphism is how a parent class refers to a child class object. Here, the class shape and the class rectangle that extends the shape, and class circle that extends the shape, class triangle that extends the shape, and class test polymorphism too. Now let me run the program. In fact, any object that satisfies more than one ISA relationship is polymorphic in nature. For instance, let's consider a class animal and let cat be a subclass of animal. Okay, and so any cat is animal. Here cat satisfies the ISA relationship for its own type as well as its superclass animal. Note that it's also legal to say every object in Java is polymorphic in nature, as each one passes an ISA test for itself and also for object class. Let's talk about static polymorphism. In Java, static polymorphism is achieved through method overloading. Method overloading means there are several methods present in a class having the same name but different types, order, or number of parameters. At compile time, Java knows which method to invoke by checking the method signatures. So this is called compile time polymorphism or static binding. The concept will be clear from the following example. Here is the class demo overload and the vehicle. The vehicle public, the classes are there, and the public the integer, that's integer x and y and z, and double x and integer y in public integer at and the integer x and double y. Now let's run the program. In the above example, there are 4 versions of add methods. The first method takes 2 parameters while the second one takes 3. For the third and fourth methods, there is change of order parameters. The compiler looks at the method signature and decides which method to invoke for a particular method at a compile time. So now, dynamic polymorphism. Suppose a subclass overrides a particular method of superclass. Let's say in the program we create an object of the subclass and assign it to the superclass reference. Now, if we call the overridden method on the superclass reference, then the subclass version of the method will be called. Have a look at the following example. The class vehicle, the public void move, and the vehicles can move. There is the class of motorbike that extends vehicle, and the system motorbike can move and accelerate too. Now let's run the program. Here is the output, and that prints motorbike can move and accelerate too. It should be noted that in the first call to move, the reference type is vehicle and the object being referenced is motorbike. So when a call to move is made, Java waits until runtime to determine which object is actually being pointed to by the reference. In this case, the object is of the class motorbike, so the move method of motorbike class will be called. In the second call to move, the object is of the class vehicle, so the move method of vehicle will be called. As the method to call is determined at runtime, this is called dynamic binding or late binding. So that's it. Thank you, Dr. Lu, for watching the video.